Hello, good morning, and welcome to Algebra 2, where we'll be looking at topics like algebraic expressions, formulae, substitution, linear equations, and so on. So, as usual, we start off with God's word, and this is what it says. For the Lord is good, his mercy is everlasting, and his truth endureth to all generations. So let us have an attitude of gratitude and let us keep our faith in the goodness of God. It doesn't matter what we are going through, God is great, and of course, his mercies endure it forever. I'm Teacher Alton, and let's go straight into our questions. Question number 1. So we are asked to solve this equation, or it's an inequation, and we are given 5 minus v is less than or equal to 2v minus 1. So let's see how we go about solving that. We use the same approach for solving equations. And if we want, this is one method, we can add v on both sides. So this becomes 5 minus v plus v is less than or equal to 2v minus 1 plus v. So in doing so, this will cancel out and we are left with 5 less than or equal to 2v plus 1v here will give us 3v minus 1. So we need to get our constants on one side. So let us add 1 on both sides. When we add 1, of course, this will be eliminated. This becomes 6. And we have 3v. And then all we can do now is divide by 3 on both sides to solve for v. So this will give us 2 is less than or equal to v, or if we read it from this side, this is saying that v is greater than or equal to 2. Hence, write down 3 integers which satisfy the above inequality. So once it's greater than or equal to 2, your 3 integers can be 2, 3, and 4. Any values greater than or equal to 2. You may be wondering what's another approach or method of solving this problem. Some of us may not have added v. Let's see how else we could have approached this problem. Okay. Right, so let's go back to this. Okay, so I added v on both sides to eliminate v, but what if we subtracted 2v on either side? So in this case, we'll have 5 minus v minus 2v is less than or equal to 2v minus 1 minus 2v. In doing so, we'll eliminate this 2v here, so we're left with 5 minus 3v is less than or equal to minus 1. So we can now subtract 5 on both sides to eliminate the 5 on the left-hand side. And we get minus 3v is less than or equal to minus 6. Now, this is interesting. Once you have a negative coefficient, the number in front of the letter or variable, once that is negative, if you are dividing to solve, you must change the direction of the sign. So what do we mean? So if you are dividing by minus 3v to solve for v, this will cancel out. You will have to change the direction of the sign. And that only happens once the coefficient is negative. So this becomes v is greater than or equal to 2, which is what we had previously. So question number 2, we need to simplify. Let's do that. So simplify. If we multiply, remember, where you have the same base and you're multiplying, you will add your powers. So this becomes minus 3. Let's multiply our constants first by 2. Let's look at all the a's. It will be a cubed multiplied by a. And then let's multiply our b's. Multiply by b squared multiply by b fourth. Right, so as stated, this will give us -6, and you are adding your powers here. So this will be a to the power 4 by b to the power 2 plus 4, give us 6. That will be our answer. Expand and simplify. Well, this should be interesting. When you expand, remember you're taking each term in the first bracket and multiplying by the second term. So you multiply 5x by x, then you multiply 5x by -3, then you multiply 2 by x, and then 2 by -3. And let's see if we can do that. So 5x by x will give us 5x squared. 5x by -3 will give us -15x. 2 by x plus 2x. And then you have 2 by -3 will give us -6. And we can now simplify, bring all our x's together and simplify that. That'll be -13x -6. Question number 3. Evaluate this expression when m is 4 and n is -5. So where you see m, you're going to replace that by 4. And where you see n, you got to be careful here, you're going to put in -5. So we dividing this by 3 by m, which is 4, all squared. This will give us 8 plus 5 divided by 3 by 4 squared, 16. 8 and 5 is 13 divided by 16, 3 is 48. Express this statement as an algebraic expression. 6 times the sum of the squares of two numbers p and q. So 6 times the sum of these squares, so it will be p squared, the sum of the squares of two numbers p and q. No, it didn't say the square, the sum. It says the, right, it says the sum of the squares. So you will add a p squared plus q squared. Right, so this will give us 6 by p squared plus q squared. Now the problem did not say 6 multiplied by the square of the sum. It says the sum of the square. The square of the sum will be this. You add it to, you get the sum, and then you square it. It didn't say that. It says the sum of the squares. So you have to square them and then you sum them. So given the formula, that's question number 4. Given the formula, see what we can do here. Take this page down a bit. Right. So let's go down a bit. Question number 4. Given the formula, find the value of w corrected to decimal places when pi is 3.14 and so on. So again, we're substituting. So we're going to have to depend heavily on our calculator here. So w is equal to 3 by pi, which is 3 by 3.14, multiplied by the square root of 2 times a, which is 11.3, divided by b, 2.56. Okay, so calculator time. All right, 3 multiplied by 3.14, this will give us 9.42 times the square root of 22.6 divided by 2.56. Right, let's double check these values. Sorry. The first value to double check is 3 multiplied by 3.14. Right, so that's 9.42. 2 by 11.3 is 22.6. So let's work out the part in brackets first. Okay, not in brackets, under the square root sign, right? So that's 22.6 divided by 2.56. Right, so we're gonna get this, we wanna find the square root of 8.828125. Right, so let's preserve that. let's see if we could. Square root is really raising the power to the half. So we're going to do that one time. We're going to raise that answer to the half, which is 0.5. Okay, let's see it again. 0.5. Right, so this will be y equal sign. That will be 2.97. And we're going to multiply that answer by 9.42. Now, of course, you may be approximating your answers as you go along, right? So let's multiply that by, okay, multiply by 9.42. Right, so our answer is about 27. That should be around 28, right? So 27.9928, that'll be fine. 27.99, and we'll take that as the answer. Okay. Right, they did say corrected 2 decimal places, right? So let's keep it like this, 27.99. Now, because of approximations, when you were working yours, you may have gotten a slightly different answer, but anything close to that is fine. Okay, let's go to part B. We have an equation here and we need to solve it. So let's see. So we have 2x over 3 plus x minus 3 over 4. Right, so once you're working with fractions, let's write the 5 over 1 as a fraction. We're going to take our LCM as 12. 12 divided by 3 is 4. 4 multiplied by 2x. And then we are adding to that. 12 divided by 4 is 3. So it will be 3 multiplied by x minus 3. And then 12 divided by 1 is 12 by 5. Right, so let's expand our brackets now. When you continue solving the problem, you can now work with your denominator, not your denominator, your numerator only. So this becomes 4 by 2x would be 8x. Right, that implies that 8x plus 3x. We have moving bracket expanding minus 9 would give us 12 by 5, 16. Now we work with the numerator only because that entire expression throughout the equation is all divided by 12. So you could just simply equate the numerator values, which is what we just did. So this becomes, right, so it's always good to double check. 12 divided by 3 is 4, 2 is 8x, 4 divided by 12 divided by 4 is 3, 3x minus 9, and 5 by 12, 60. Okay, so 8 and 3 is 11x, right? 11x minus 9 equals to 60. We're going to add 9 on both sides. That's 60 plus 9. In doing so, we eliminate this. So we have 11x equals to 69. We're solving for x, so x will be 69 over 11, right? So you can leave it like that. Question number 5. Y varies directly with x as shown in the table. We need to find the values of A and B, right? So once you're told that y varies directly with x, you are basically looking at this expression y is equal to k times x. Usually the first step is to solve for k. Now you can only do that if you have two known values, one for y and one for x. And let's see where we have known values. There you go. We have two known values here, one for y and one for x. So let's substitute. When x is 2, y is minus 6. So we're going to put minus 6 for y. And when x is 2, right? So this gives you a nice equation. So you divide by 2, and this will cancel. So we get an expression where k is equal to what? Minus 3. So we can now rewrite that first equation in equation 1 by replacing the value of k by minus 3. And then, of course, we take each pair of values and solve for a and b in turn, right? So let's do that here now. So we found k as minus 3, so the equation becomes y equal to minus 3. Let's look at the first pair. When x is a, y is 4.5. So you put 4.5 here when x is a. So to solve for a, you divide both sides by 3, by minus 3, sorry. So this will give you minus 1.5 is equal to a. I do the same thing there for b. When y is b, x is 4. So let's do that. Using the same equation here, when y is b, x is 4. Right, so b will be minus 12. Let's go to question number 6. So we have a pair of simultaneous quadratic equations, and let's solve. So you have 2x. So from this first equation, we're going to use the substitution approach. So from here, we can see y is equal to 3 minus 2x. So we're going to substitute for y in the second equation, the expression 3 minus 2x. So let's do that from the top. And we're just going to have to take our time with solving that. So where you see y, we're going to put in 3 minus 2x. So this becomes 3x squared plus 3 minus 2x all squared. And that will give us 13. So we need to be very careful with expanding this bracket here. Right, so let's go ahead. So we have 3x squared plus, you multiply in 3 minus 2x by itself. And we know to do that, you multiply 3 by 3, then 3 by minus 2x. Let's do that. That'll give us 9. 3 by minus 2x is minus 6x. And then you do minus 2 by 3, which is minus 6x. And then you have minus 2 by minus 2, which will give us 4x squared. And that'll give us 13. Right, so it's 9 minus 6x plus 4x squared. So let's simplify. You have two terms with x squared, so this will give us 7x squared. Then we have minus 12x. And if we subtract 13 on both sides, to eliminate that 13 there, you get minus 4 equals to what? 0, because 9 minus 13 will give us minus 4. You are subtracting 13 on both sides. So you subtract 13 here and 13 here. So this cancels out to give you 0. And 9 minus 13 is minus 4. So we end up with a neat quadratic. Now, in the business of solving quadratics, you need two numbers whose sum is minus 12 and whose product is a by c. A by c is minus 28. So let's see if we could get that combination. Products of 28. I'm seeing 7 by 4 is 28. I'm seeing 14 by 2 will give us 28. Any other products? I'm not seeing any. Right, so let's see if we can operate with this 14 and all right. Now remember we want minus 28, right? So let's adjust this a bit. Minus 14 by 2 will give us minus 28. And when we add them, we're going to get minus 12. So these two could hold, these two numbers. So let's replace it. So you have 7x squared minus 14x plus 2x minus 4 equals to 0. And of course, we factorize each pair. That's factorization by grouping. You have x minus 2 plus 2 into x minus 2. Right, so you know you're on the right track if your pairs of brackets are identical in terms of the factors x minus 2. So we can now write this as 7x plus 2 by x minus 2, and that will be 0. So one set of values is either either 7x plus 2 is 0. So you're solving, right? And when you solve this, you're going to get 7x is minus 2, x will be minus 2 sevenths. Now, when x is minus 2 sevenths, you can now solve for y right here. Let's do that. So when x is minus 2 sevenths, the corresponding value of y will be 3 minus 2 by minus 2 sevenths. So this will be 3 plus 2 2s are 4. 2 negatives gives you a positive 4 sevenths. So this will be 3 and 4 sevenths. Right, so that's one pair of values for x and y. And let's take the other value now. So the other scenario is where you have x minus 2, in which case x will be 2. Right, and we know y will be 3 minus 2x. So let's simplify that. So the other corresponding pair of values will be y will be 3 minus 2 by 2, which is y is equal to 3 minus 4, which is minus 1. So these are your pair values, x and y. So the first one is when x is minus 2 sevenths, your y value would be 3 and 4 sevenths. Right, so that's one pair of values here. And the other solution set will be when x is 2, y will be minus 1. Right, so these are your solutions there for that question 6, pair of quadratic equation. And question 7 is a beautiful sum, you know. Let's see if we can look at question 7. Right, let's see how is the best way to tackle question 7. Let's erase this here. Right, they want us to express that expression there, which is quadratic expression, in another format. That's called completing the square technique. Now, this tends to give students a lot of trouble. So I'm going to use an approach which I hope you'll be able to follow in solving that, right? So let's start it. Because it's special, we're going to use green. All right, so what do? They want us to write this expression 2x squared plus 8x minus 5 in this format. And I usually put it next to it one time, right? X plus h all square plus k. So at the end of the day, you must have your expression looking like what is on the right-hand side. Right, now the first thing you do is you can factor out 2 right here. So first two terms, this will be x squared plus 4x. Right, now I'll be switching some colors in between on you, so you'll pay careful attention, right? So we haven't really adjusted anything here as yet. We simply take the first two terms and we're going to try to write it like this. So already things are shaping up. I'm making some comparison one time. We have the A value here, it's the term outside the bracket. So the next step is we need to write this expression as a square. So we need to form what is called a perfect square. Now, how do you do that? And this is where the change of color is going to come in. You see this term here? The rule is if you form in a perfect square, you're going to add, right, b over 2 squared. Now, b in any quadratic expression is the number or coefficient, the number in front x or the coefficient of x. So we need to add in brackets. And watch how you're going to write this. Right. B over 2, well, b is 4 in this scenario. So you're going to add your 4 over 2 square in bracket, right? And you're going to continue writing the rest of the problem, right? So now you notice we have added an additional term, an additional number to the expression. So we need to subtract that expression or that number, sorry. Let's see what a number is. Now 4 over 2 squared. 4 over 2 squared, let's work that out. 4 divided by 2 is 2. 2 squared is 4. So what we have done in bracket here, this is really 4, right? Now, I've written this line. So the additional term we are putting here is really 2 by 4, which is 8. So to balance off that equation, right, we need to subtract 8 because you have just added a number 8 to the expression 2 by 4. So you need to subtract 8. Now, once you have done that, you can now write that expression in brackets there as a perfect square. So the perfect square will be simply x plus 2 whole square. And this 2 is the value we have gotten here. This is this value. The 2 is this value. So whatever that works out to be, you are adding that. Now watch this. Minus 5 minus 8 is minus 13. I think we have just finished that problem right there. Without you knowing, it's done. Let's see why I'm saying that. So let's compare now. This 2 is the value of a here. The x is this x here. The plus 2 is this here. Well, the square is the square, and the minus 13 is this k here. So let's just write down those values. So we have just written down that expression as a perfect square. So your a, therefore, your a will be 2. Your b, sorry, in this case, your h will also be 2. And your k will be minus 13. And the question says, what is the minimum value? Well, the minimum value in this case will be always be the constant, right? And that constant will be the value of k. So your minimum value is always, in this scenario, is always this value on the end, which is minus 13. Now, just to be sure that what we have here is equal to the original expression, so the sum is finished, but I'm saying just to be sure that the expression we have there is similar to the original expression, let's just do a quick check back here. So this is 2 multiplied by x squared plus 4x, right? This will be plus 4 minus 13. Well, when you remove the brackets again, 2x squared plus 8x plus 8 minus 13. And this will give us 2x squared plus 8x minus 5, which is the original expression we have up here. That's the original expression. So we know the answer there is correct. Okay, so you be safe and God continue to bless you. Remember, continue to trust God and keep a positive attitude. For the Lord is good, his mercy is everlasting. Bye for now.